So, hello everyone, I'm Vincent Ngai from Hong Kong, and you can find me online at SerKo. Thanks to Vue Amsterdam for having me. This is my first time in Europe, and Amsterdam is my first stop. I'm really glad to be here. Thank you. I'm honored to have recently become a part of Vue team for working on the Vue language tools, including the Vue VS Code extensions and Vue TSC. I'm also a Vue use team member and a co-founder of Vue AI for building some AI stuff like agent skills for Vue. I'm also a Nuxter and contribute to the Nuxt ecosystem and managing some libraries too. So I'm now based in Taiwan, and I'm part of the Golang Taiwan and Python Taiwan communities. So if you are interested, feel free to check out my links below. So as part of the Vue language tool teams, before we dive into today's topic, I'd like to share a quick updates on Vue language tools from the past few months. From the end of last year, we launched an issue cleanup plan, and after several months of effort from our team, we have now closed nearly 80% of the issues and resolving multiple bugs that have remained open for many years. So we are now getting closer to our plan, to our goal. Next, I will highlight a few of Vue language tools updates to share with you. First, we performed key type alignments for v-for. And when using v-for, the for loop in the Vue runtime actually aligns with the JavaScript behavior, which will converting number keys to strings. So in the recent update, we stringify number keys in objects in the language tools to align with the Vue runtime. I believe many people has experienced some random highlight issues over the years, right? We have finally fixed them and also improved some syntax highlight as well. So everyone should have noticed some improvement recently. And next, I'd like to introduce our brand new features, rich hover message. So after you define props, emits, or slots in Vue components, when you use the component in template, you can just hover on it and see those definitions in beautiful format. And the best part is, it's all auto-generated. You don't need to change a single line of your code, and it works out of the box of all UI libraries like Nuxt UI or Prime Vue. So this is currently an experimental feature. To try today, just go to VS Code extension settings to enable hover rich in Vue extensions, and that's it. We'd love to hear your feedback. And finally, shout out to Johnson for coming up with this amazing feature. We hope to bring you a unique and better developer experience than any other frameworks. There's more new features and bug fix over the past few months. If you are interested, you can search Vue welcome inside the Vue VS Code command plate and see the full release notes and highlights of the Vue recent updates. Oh, one more thing. We know many of you have been looking forward to TSGo support in Vue language tools, and we feel the same way. Since TSGo doesn't yet have a complete API design for the third-party plugin, we are actively working with their teams to discuss the direction of the API. At the same time, we are also exploring other possible solutions and planning to build some POCs, so stay tuned. And now, let's get started with today's talk. When tree shaking fails, security risk in Nuxt and Vue. In this talk, you'll get a complete understanding of what tree shaking is, what happens when tree shaking fails, and how that relates to security. I'll also introduce some common pitfalls that break tree shaking, including what side effects and how they affect tree shaking. We'll review real-world tree shaking pitfalls and examples, how to detect tree shaking failures, and how can we fix them. Oh, sorry. I'll share some coding techniques that makes tree shaking works properly. So today's talk will mainly use Vue and Nuxt as examples, but I believe the concepts can also apply to any JavaScript or TypeScript project. Especially if you are a library maintainer, I believe today's content may be helpful to you. Let's get started from the basics and go deeper step by step. So what's tree shaking? Imagine your project uses a library that exports hundreds of functions, features like Lodash, but you only use one or two of them. If you bundle the entire library into your website, that wastes resources and can hurt performance, right? With tree shaking, only the exports you actually used are bundled. It's like shaking a tree so the dead leaves fall off, leaving only the useful leaves. So what happens if tree shaking is not done well? For sure, the first we can think about is larger bundles and worse performance. But the consequence can be more serious than many people expect. For example, if you had test code or internal features that are not properly shaking, they could end up being bundled into your front end as well. Things like internal APIs, endpoints for testing, admin panel URLs, and so on. And that could potentially lead to further issues. At a more serious level, sensitive information can leak too. Your backend logic and even secrets can leak into client bundles if tree shaking is not done properly. I'll explain how this happens and how to prevent it in this talk later. So, we all know that tree shaking is smart, right? It can remove unused code at build time. But have we really verified that all unused code is truly removed? This is the key point of this note. Tree shaking can be lazy. It doesn't always do everything you expect. Next, I will walk through some of the most common pitfalls that breach tree shaking. The first one is CommonJS. Even though we rarely use CommonJS directly when developing Vue application nowadays, if your project uses a library written in CommonJS, it may not be tree shakeable. Let's look at an example. Imagine there's a CommonJS library with just 2 exported functions. Then we have an index file that only uses add function from the library. After that, we bundle the project. You notice that the sub function, even though we never use it, it still gets bundled. In this example, we can make a small change to help the bundler perform static analytics more efficiently. Right now, we are recurring the entire module, so the bundler has less information about what happened at runtime after the module is required. If we change it to a named required, we give the bundler more clues, and it can see that we only used add from the beginning when static analytics in the list. In some bundlers, it can be tree shaken, but not everyone guarantees support for this. Also, if you move required inside a function, it becomes even harder to detect, and tree shaking may fail again. One more case, let's say you use named required and place it at the top level, but what if the library you are using look like this? This is actually a very common pattern, splitting feature into multiple files, and we export them in them or from library entries point. When you import from it, even with a named required at the top level, it still cannot be tree shaken. You may wonder how common this pattern really is. If you do a quick search on GitHub, you will find over 45,000 results written in this way. So it's far from rare. If your project uses ES module, bundlers usually get better static analytics for tree shaking. But it's not a silver bullet. If the code is structured poorly, unused code can be still be bundled. Let's convert the previous common JS example into DSM and use it in a Vue component and bundle it again. You still see an unused function is bundled. Can you spot why? Is it because we didn't use the name import? If you switch to name import here, the IDE reports an error. Why? Because this library only has a default export, it combines add and sub into a new object and export that object instead of export each function separately. This style is not tree shake friendly. To be clear, I'm not saying I never used export default with objects. It's fine for many config files when the object is truly one unit. A GitHub search for this style returns millions of results. Although many of them are valid use case, there are still plenty of use cases where unrelated things are mixed together in one export. Back to our example. If we want these 2 functions to be exported individually, we can remove the default export from the library and change it to export add and export sub. That's what we call a proper named export, and this is tree shake friendly. You can also place export directly before each function, and this is also a valid named export. Next, still in ESM, after learning to use named import and export, what if I want to import many functions from one library? And I use namespace import for the whole module. Can it still be cheat chicken? Yes. Even with namespace import, if static analysts can see that only the add function has been used, bundlers can still cheat chicken correctly. What if functions selection is dynamic? Can it still be analyzed? Yes, because the code explicitly reference add and sub from the library, so the AST is still analyzable. So one more change. If I chose the function named as a string key, can bundlers still analyze it? At first, it looked possible. But no, performing static analyze in this scenario becomes more complex and hard to detect. Most of a bundler cannot handle this. So now we have covered some basic import-export pitfalls. Let's do a quick exercise. We use ESM, named import, and named export in our app. And we only use one export system.version. In theory, the bundle should only include version, right? Let's check the output. You'll notice that other code from system is still bundled, even though we never import it directly. Why? This leads to the next key topic of today, side effects. This is another major pitfall for cheat sheet. If I had to describe side effects in one sentence, it is affect outside scope. Let me quickly explain what's that mean. In this function, we change the count variable outside the function since it affects our outer scope. The line that's increased count is a side effect. In other words, modifying a global variable is also a side effect. In practice, the most common way side effects happen is by calling APIs with side effects, such as console log. The console object exists outside the function, and the effects happens in the browser console where a text message is logged. So let's see what else APIs are also marked as have side effects by the bundlers. Any APIs that change browser states like console log, we mentioned before, are all side effects. The APIs which access the networks, perform DOM interaction like changing CSS, elements that affects the UI, or the APIs affect the event loop, these APIs are all marked as having side effects. So next, JSON parse and JSON stringify. Who thinks these APIs would be marked as have side effects by a bundler like roll up or roll down? Please raise up your hand. Oh, seems there's no. Okay. It seems doesn't have side effects, right? They really would be marked as have side effects. And the reason is they can throw an error. Once an error is thrown, it definitely affects the outside of the program, right? And when the bundler is doing static analyze, it does not check the input will cause the error or not. So throw and any APIs that can throw is marked have side effects. So it turns out the API is actually more than we expect. And finally, I want to mention object assign. If you use it to change an object which is outside of the scope, of course, there's a side effects. But if even both the source and the target objects are in the same scope, the bundlers will still mark it as side effects. Although it's a bit unreasonable, the main reason is, again, static analytics is hard, so bundlers take the worst case path here too. From my observation, many libraries functions that are marked as having side effects are mainly because of they use this object assign, like assigning some default options with an object. So be careful with this one. There are actually many or more APIs that marked as side effects, and different bundlers may make different decisions. Also, bundlers may become smarter over time, right? So let's keep in mind to watch out for APIs or behaviors that have side effects. So how do side effects impact cheat-sheeting? Let's go back to the previous example. In the no side effect version, system.js has two exports. settings, and version. In our app, we only import the versions. We can see only version is bundled. Great, since setting is not imported and used here, right? So the use settings function is checking correctly. Now we add a side effect line console logs to use settings function and bundled again. You see that even setting is not imported, the use setting function still get bundled. Why? Because use setting has been called and it triggers console log, which is a side effects API. The bundler will keep the code that has side effects to ensure the results remain consistent before and after tree shaking. So we have talked for a while. So how exactly can tree shaking affect security risk? First, in many modern web app projects nowadays, we don't have only the front-end code in our code base, right? For example, if you use an SSR framework like Nuxt, your front-end project may share some code with your backend, like configs or schemas. Once the code are shared, it means if your tree shaking goes wrong, some backend code or config can accidentally get bundled into your front end. Let's assume we have a shared file that contains some shared URL configs, and you also put some secret data in it. So you just think, oh, it's fine. My front end only imports the public value, so that the secret stuff is unused. So tree shaking will handle and remove it, right? But after handling, you may see all the secret data is included in the output. Wait, I only used the public home URL here. Why did everything else get bundled? The reason is inside the setup client, it may throw an error, so the bundler treats calling this function as a side effect call. And because these calls use secret key as an input parameter, so it gets bundled too. Of course, this example may be a bit extreme. You probably won't hardcode a secret key in as a string, right? Instead, you may put it in an environment variables, or in Nuxt, you may use the use runtime config API. But things like private URLs or backend logics written directly in code really can leak this way. This example shows a more serious real-world impact when tree shaking gets lazy. If you feel like the example I just mentioned were not real enough, how about some real-world cases? The truth is, there are actually more of them you expect. Even in libraries I personally use, I have found many of them can't be tree shaking because of side effects. Let me pick one. Sort. Anyone is using sort here? Raise up your hand. Great, many of you. So now imagine you define your user schema with sort, and in some files, you also define 50 more other schemas. Some of them may be just for backend only. And in your front end, you only import and use that single user schema. When you bundle, you'll find all 50 schemas end up bundled. The reason is the function that sort uses to define schemas like z.object, z.string are having side effects. If someone inspects the JavaScript code of your website, they can know how your data format are validated and combined with other information leaks mentioned earlier that may further increase the security risk of your website. So, after introduce these cases, if you find that your own project may also be affected, how can you test or detect it? Let's start with a more serious issue. Is there any secret data get bundled into the front end? First, locate the file in your project where you keep secret data. Then find exact lines where those values are defined. Next, add a line of code that has side effects like console log, and print a very long and unique string. Then run the bundle build. So after bundling, search inside your build output folder for that long unique string. If you find it, open that file and check the surrounding code to see whether your secret data is included. So this method is just that low tech, right? But it's surprisingly effective. So if you are sure your project doesn't contain some secret things, but you want to see whether unused modules are being bundled, you can use some bundler analyzer tools like Nuxt Analyze, Vite Bundle Analyzer to visualize your bundle and see what got included. If you really want to go to line by line to see which part of your code were bundled, there's a VS Code extension called Cheat Visualizer that uses source map to mark which part of your code actually end up in the bundle. So shout out to Anthony Fu for creating this awesome tool. So if you discover that your project actually have cheat checking issues, how do you fix them? And how can you prevent cheat checking from getting lazy again in the future? The simplest approach is split files properly. If you originally put different types of data in one file, see if you can separate them. Or you put secret and public things together, so see if you can split them into separate files. If your project is large and you can't just move files around, but you still want to fix cheat checking issues caused by side effects, you can try a cheat checking annotation called pure that can, and the usage is very simple. Just add the pure annotation comment right before a function call that have side effects and telling the bundler that the following function call has no side effects. Then the bundler will be able to cheat check it away when the client export isn't used. But there's a problem. What if I call a function with side effects many times? Doesn't my code become full of pure annotation, right? In fact, you can just place it inside the function right before the line that actually caused the side effects. For example, if you put it before console log, the bundler will mark console log have no side effects here. But what if a single function has a ton of side effects? Then the functions become ugly again, right? If this way doesn't work and that way doesn't work, how do we solve this problem? That brings us to the second annotation, no side effects. If a function contains many side effects, or you don't even know where the side effects are, you can just add a no side effects annotation above the function that then any call to that function will be marked as a pure call. So that's how cheat checking annotation works. So up to this point of this talk, we've learned cheat checking is about only bundle the code or module that we actually use. And when cheat checking fails, the worst case could be secret leaks. We also saw how CommonJS and incorrect ESM usage can break cheat checking. We talked about side effects and how they impact cheat checking and common web APIs that marked as side effects. We saw how back-end secrets could end up bundled into the front end, and we looked into the real-world case. Finally, we learned different ways to detect cheat checking problems. And we also learned some coding skills to make cheat checking work properly. So lastly, I want to share some story about cheat checking in the real world. Let's start with schema library. Remember the sort example I mentioned earlier? The first time I noticed this issue was in 2024. Back then, sort 4 hadn't released yet, and I tried to optimize cheat checking for sort. But because of its API design function chaining, it's not really possible to optimize it with cheat checking annotations. Around that time, I started to work on one of Anthony Fu's project, and it was using ValidBot, which is a sort alternative. So ValidBot also wasn't optimized for cheat checking at that time, but after we reviewed the code base, seems its API design can be optimized. So we shipped a PR together to ValidBot to optimize the cheat checking. I also sent another PR to further improve the cheat checking after that. So after that, Sort released version 4 in April last year. It introduced Sort Mini, and that API is very similar to ValidBot. It also claimed to be cheat checking friendly, but I had already switched to ValidBot at that time, so I didn't dig deeper into Sort Mini. Until a few months ago, I started to prepare for this talk and want to use Sort as an example. That's when I found out Sort Mini still have cheat checking problems, and it's actually exactly the same that ValidBot had before. So I opened a PR and optimized cheat checking for over hundreds of the APIs in Sort Mini, and it got merged about 2 months ago. The last thing I want to share is the current cheat checking situation in the Vue ecosystem. Luckily, Vue core marks most of the API's no side effects annotation. So if you define some reactive states, but you never use it, it can be cheat away. As of the Vue ecosystem libraries, in 2024, I sent a PR to Pinia to optimize cheat-shaking. So if you define a store in Pinia, but you never use it, it can be cheat-shaken right now. And last year, I also sent a PR to Vue use to optimize cheat-shaking for over 100 of Vue's APIs. For instance, if you use like create global states to create a store with Vue use, but you don't really use it, it can be cheat-shaken away too. So congratulations to all Vue developers. The library we commonly use in Vue ecosystem are now optimized for cheat-shaking. All right, so that's my talk for today, and hopefully it creates some positive side effects for you. Thank you.